Hello everyone, welcome to our YouTube channel. And in the previous session, we have covered the basic interview questions for mechanical as well as CAE and R&D and quality control engineers. So we have already covered part 1 and part 2. If you're not aware of these videos, please do check these videos to learn more about these things. And if you're new to this channel, please do like and subscribe. Yep, and in the today's session we are going to deal with design and development process. So here what actually we do follow the standard processes to design the particular components, and once it is designed, how to deal with the development process. Okay, and before that we do need to know what is code. So the code is, give me a minute. Yep, sorry. And we were dealing with the codes, right? So why we actually requires the codes? For example, you're dealing with the ASME standard, so they do have some codes with respect to the standards. For example, so if you are going to deal with pressure vessels, you need to use ASME standards. There will be a code for specific code for the pressure vessels, so that code you need to follow to deal with. For example, if I'm using ISO 128, so that will deal with the code 128 will deal with the shipbuilding. And if you are dealing with ASME Y14.5 code will let you know we are going to deal with GD&Ts. And even ISO 129 and 128, they does the same GD&T and notifications for the dimensions and tolerances. So even with respect to DIN and BS, DIN is a German standard and BS is the British standard. And so like this way this code will help us, and you can see why the code is used. So it provides a set of rules that specify the minimum acceptable level of safety and the quality for the manufactured, fabricated and constructed projects. Next comes code and standard grouping. So with respect to the grouping, we have the three groups. One is system design code, so what and all the design code will be referring, and then material standard with respect to material, so which and all the standards we use. And then next comes is dimension standards, so what and all this standards we do follow in the dimension standards. Okay, these are the three set of standards. One is system design standard, material standard and dimension standard. I hope it is clear. For the material standards we do refer ASTM, that is American Society of Testing and Materials, and ASME is in mechanical engineers, and same thing. Remaining B16 is for dimension standards. So in detail we can cover material standards, which covers manufacturing process, so chemical properties, mechanical properties which that particular material has, the heat treatment process requirements, as well as the mechanical testing requirements, NDT and inspection requirements will be covered in the material standards. And then requirements for the materials, the types of components, and design requirements, fabrication, assembly, installation requirements, inspection and testing requirements. And the dimension standards, it covers the standard C size, sheet size. I forgot the ISO standard, let us just check it once. So ISO standard, there will be a coding. With respect to that coding, we'll have the standard sheet formats, so E0, A2 and all comes under it. And then next comes is the different standard for the components, giving the product specific requirements in general, inside and outside diameters, so with respect to that diameters how we need to define it. And then wall thickness, and then pressure, temperature, ratings and all dimension standard covers. Next comes is the design and development, so NPD, new product development process. So even product development process, and DMAC also we can consider in that, so the product newly designed one. So here, so before getting into this NPD, so the first question is, there are companies, set of companies, tier 1, tier 2 and the OEM. So OEM companies in the sense original equipment manufacturers, so they are going to manufacture the components. The tier 1 and tier 2 will help as a supply chain, so what and all the basic requirements are there. so what actually they need to do, and also designs they will prepare, and these all things they will do, and they will send it to the OEMs. And with respect to tier 1 and tier 2 information, the OEM will manufacture the components, and tier 1 tier 2 will help us to manufacture that particular component, and then they will deliver to the customers with respect to their requirements. So that is main case, right? So these are this following steps we do follow inside it. So first one is the getting design data. So once you reach out the customer, he'll ask for the samples, right? Drawing or the part sample, we do ask them. So once we get the design data, what we do, will study on it. So feasibility study, so whether we can check whether this part can be developed by us or not. The first one, if it is possible, we do say yes, otherwise we'll just stop it over there. Can we able to provide the required tolerance or not? So even that matters. So whatever the equipments or whatever the tools we are using, that can produce that much of tolerance or not, we do need to check these things. And then, do we have required tools, set of tools or not? Main thing, right? So once we deal with the feasibility studies, so once it's satisfied, we do go ahead with the getting approval and development. That is PO form, purchase order. So once the purchase order submitted, so if you get the approval, we start dealing with the particular design process. That is by just developing this one, APQP. So that means the planning of advanced product quality planning. So this is just the standard set of plannings we do follow inside it. So the steps we just will go through these things now. So first one is raw material receiving date. So when we gonna receive the raw materials, and then gauge tools and fixtures preparations. So once that is done, we are going to deal with these all the things. So gauge tools as well as the fixtures, then first trail and the preparation of samples. So with respect to our design team, so they are going to deal with the design. So they will send the design. With respect to that, we'll just run the first trail. Okay, during the first trail only we start preparing the manufacturing design of manufacturing process. Okay, then once it is done, we prepare the samples. Once this sample is prepared, we just send it to the customers again for checking purpose. So that is PPAP sample, production part approval process. So once the PPAP has been sent, if the PPAP got approved, we will start generating the lots with respect to that components and all. So PPAP lot will be generated, action plans will be generated, and then with respect to this, we go ahead with the mass production and then hand over the product. That's all. So once your design is ready, once you produce your sample, once you get the approval, you just hand over your whatever the design is there, as well as the whatever the process, like design manufacturing process you have created, that you need to hand over it to production. So they will follow the same set of procedures whatever you followed for the sample preparation. Then your mass production will start from there. So these are the action plans. So there are two types of action plans. One is corrective actions and preventive actions, right? So once your delivery is done, you need to tackle these. And then these are the basics questions. So if you are applying for the NPD, so that is what are these Kaizen, Pokayok, and these 3M and 3M tool knowledge, like these are the lean tools which we use to deal with the manufacturing process to avoid more failures and the process time delay and all. And drawing design study, so how we need to study the drawings, that matters a lot. CD&T also you need to know. Measuring instruments, so next PPAP process, how it does, and process flow diagram. So you do need to know these things. PFT. So in detail you can just refer the book. So I have just covered some of the basics here, so you can follow this. Otherwise, if you want in depth details, you just follow some of the handbooks and all. So first one, APQP, advanced product quality planning. So these are the few things we are gonna deal with. First one, the introduction. So what actually it is. It's a framework of procedure and the techniques used to develop product in industries. Okay, the standard procedures what we follow inside the industries, so that is known as APQP. To particular, if you want to develop the particular product, you need to follow the standard set of plans or the procedures. In the history, big three, that is GM, Ford and the Chrysler has gone through these things, so they have deployed these APQP set to develop and design their particular components to make sure the suppliers met the customer quality requirements for each component supplied. So that is what this process is. Then the 5 phases of APQP. The first one is to plan and define the program. Once it is done, you need to deal with the product design and development verification. Once the product design and development is done, you need to define the process design and development, the process for manufacturing, right? Once you define these three, the next step is to deal with product and process validation and the production feedback, how the production is going on, what and all the process validation we need to follow over there. And then phase 5, give me a minute, sorry for the inconvenience. And the product process validation. So what actually here we do, so we just maintain the regular visit into the production to check whether everything is going fine or not. The production feedbacks, if something goes wrong, or if we are facing some tolerance issues and all, so minor issues and all, so we just deal with these things. And once everything is done, we do launch it, and then we follow the corrective actions. Next comes the phase 1, phase 2, phase 3 in depth we are going to deal. So in the phase 1, define the program, design the goal, reliability, quality goals and all, bomb generation, then process flow chart we do generate over there. Then again preliminary list of special characteristics. Once if you define these all things, we do deal with the second phase. Over there we are going to deal with DFMEA and DFMA, that is design failure mode effect analysis and the design for manufacturing analysis. So these things we deal with the product design. Here NPD design engineers will work. Design verification, design review, then prototype, then engineering drawings reading, and the engineering specifications we do follow over there, the material specification board and all we need to take. Then change control for drawings, new equipment, tooling and systems, whatever we needed, we'll just everything will take it up here. And then gauges and testing equipment requirements, everything here we just grab everything, and then we'll start with the process design. So in the phase 3, quality system quality system review, and then once you deal with this review, then we define the process flow chart, then flow layout we define. And for the manufacturing process, designing of the manufacturing process, we define the flow chart and the flow plan layout, then matrix, characteristic of matrix. Then again with respect to same as that of TFMEA, we define the process failure mode and effects, pre-launch control plan, process instruments. Then after everything is done, so last we deal with the packaging standards and specifications, how we gonna do. The phase 4, product and the process validation and feedback. So significant production run, so how much is needed, only that much we run. And then measurements, system analysis, MSA, then process capability studies, how the studies is going on, how the process is going on. The production part approval process, PPAP generation here. So once you get the approval, we start the production validation, then packaging evaluation, production control plan. So how we need to control the production, how much we need to generate and all, we do consider here. Once everything is done, last step is assessment, corrective action and the continuous improvement. Here reduce verification, improved customer satisfaction, improved the delivery performance, effective use of lessons learned. So these are things will be covered over there. And next, coming to the benefits here, so higher quality, reduced cost, then improved customer satisfaction, decrease in development lead time, improved communication, and return of investments we do find out over there. Ultimately provides the quality product on time at lowest cost. So this is the funda of APQP. You need to remember. So next we are going to deal with lean tools. So I hope the topics which we have covered are clear. So what actually the design and manufacturing process we follow, how the APQP will help us to just recognize these all the things, and how we design everything. I hope this is fine. So in the next session we are going to deal with the lean tools as well as some of the things. Thank you all for watching. Please do like and subscribe our channel.